Code and mathematics are inherently abstract. They exist as pure logic. But to execute that logic, it must physically collide with the material world, forcing electrons through the silicon pathways of a microchip. This intersection creates a legal friction point in India. The country is experiencing explosive growth in artificial intelligence and machine learning patent filings, yet its primary intellectual property law explicitly bans algorithms from being patented. This diagram illustrates the governing statute, Section 3K of the Patents Act 1970. The text is unambiguous. It categorically excludes mathematical methods and algorithms from patentability. The statute contains a specific qualifier, the phrase computer program per se. That two-word Latin phrase is the hinge upon which India's software patent framework rests. It dictates that the law does not issue a blanket ban on all software. It only prohibits software claimed in a vacuum, devoid of any technical context. Because of this precise wording, Indian courts and the Indian Patent Office actively grant software and AI patents, provided the claims are directed to the technical execution of the algorithm rather than the code itself. To secure protection in this jurisdiction, developers must stop treating their invention as pure code. The strategy requires framing the software around the technical effect doctrine, a legal standard that has moved from requiring physical hardware to focusing on computational results. There is a widespread misconception among practitioners, stemming from the outdated 2016 CRI guidelines. Many still believe that securing a software patent requires the invention of physically novel hardware. For years, this interpretation caused examiners to routinely reject valid software patents. Unless applicants could prove they were soldering entirely new microchips, their application stalled. This infographic tracks a judicial pivot. Between 2019 and 2024, courts permanently decoupled software patentability from physical hardware. Look at the Raytheon and Microsoft decisions. The courts explicitly struck down the novel hardware prerequisite, lacking any basis in law. These rulings established a clear standard. Software operating on a standard general-purpose computer is eligible for a patent, provided it improves the overall functionality of the system it runs on. The 2024 Ab Initio ruling formalized this by defining exactly what constitutes a technical effect. The court ruled it is the bridge or connection between an input and a processor. It is not about physical nuts and bolts. The courts now recognize specific improvements: enhanced processing speed, decreased memory consumption, and parallel processing capabilities all qualify. If an innovative input simply allows standard existing hardware to compute an output more efficiently, that constitutes a valid technical effect. A technical effect is now defined entirely by computational enhancements running on standard processors. AI developers do not need to invent new hardware to protect their algorithms in India. This judicial doctrine has now been formalized. The CRI Guidelines 2025, effective July 29th, codified the technical effect standard into a mandatory examination framework. This excerpt from the examiner's manual outlines a strict three-step analysis. Step 1 requires construing the claimed invention as a unified whole. Step 2 is the core filter, where the examiner searches for substantial technical specifics, separating practical execution from mere abstract ideas. To pass this step, the invention must produce a concrete, reproducible improvement in a technical system. That means demonstrating outcomes like a measurable reduction in computational load or an improvement in signal fidelity. If the invention produces an abstract improvement in information content, like a better business forecast or a standard diagnostic output, it fails this step. Finally, Step 3 provides the conclusion. If a genuine technical effect is established back in Step 2, the Section 3K exclusion is defeated. Once an application clears this third hurdle, it proceeds to standard patentability examinations, testing for novelty and inventive step. Passing the 2025 CRI framework hinges entirely on presentation. The AI model cannot be framed as a sophisticated mathematical abstraction. It must be written as a concrete technical solution to a real-world technical problem. Let's apply this three-step test to a real-world scenario: an AI system utilizing a convolutional neural network to detect early-stage pulmonary nodules in CT scans. Here is the first version of a patent claim. It dictates receiving a CT dataset, applying a neural network, and classifying regions as nodule present or absent. This fails Step 2. The claim simply describes receiving data, applying an algorithm, and outputting an informational classification. Under the 2025 guidelines, a diagnosis or an informational result does not constitute a technical effect on a technical system. It is legally categorized as software per se. Now examine the revised, patentable version of the exact same underlying technology on the right. The winning patent drafting strategy requires explicitly tying the AI model to specific data processing steps and hardware interactions. The patent specification must disclose exactly how the training methodology optimizes execution memory or how it reduces the computational cost required to train the model in the first place. Furthermore, the patentable claim quantifies the technical improvement. It notes a measurable 18% reduction in false negative rates compared to conventional threshold-based analysis. By directly integrating a generated spatial heat map into a radiologist's hardware interface, the AI operates as a functional system improvement. The exact same AI invention can pass or fail subject matter examination. The outcome depends entirely on whether the draft prioritizes system architecture and hardware performance metrics over pure mathematical accuracy. The legal landscape in India demands a measurable technical contribution, but it is highly permissive of software innovations that can prove that contribution. This map illustrates the requirement for a technical context is a global phenomenon. At the United States Patent and Trademark Office, eligibility is governed by the Alice/Mayo test, requiring integration of an abstract idea into a practical application. The European Patent Office evaluates AI inventions through a strict two-hurdle test: initial technical character, followed by the convex inventive step analysis. While the EPO is generally considered the strictest on inventive step, India's single-structured test centered on technical effect aligns closely with the requirements of these major global markets. For practitioners filing AI patents internationally, the decisive factor for success is determined before the application is even filed. Attempting to broaden claims during prosecution is ineffective. The initial specification must comprehensively disclose system architecture, training methodologies, and measurable technical improvements from day one. By structuring claims around technical effect from the outset, patent applicants can successfully shield their AI innovations from Section 3K rejections in India and withstand rigorous examination across all major global jurisdictions.